Hello everyone, hope everyone is fine and doing good. So what is update? Well, update is this is gonna be the second video of the chapter kinematics #02. In the last video we discussed what is kinematics and we have seen what is the difference between kinematics and dynamics. In this video we are going to discuss displacement and distance in the context of one-dimensional and two-dimensional motion. So let's get started. So let's start with a very simple example. Suppose an insect is moving on the blackboard. There is a two possibility. This insect either can go in a straight line from A to B, and the second thing is that it can take any irregular path from A to B like this. So as you can notice, this is a straight line path. And this is a curved path, right? So in this case, what we can say when the object is moving along a straight line, so this is the example of one dimensional motion. And when the object is what here? This is an insect. So this insect is moving along this circular path, and this path is lying on this white board. We called it as two-dimensional motion. So the point is, when any object, or you can say particle, travels along a straight line path, then it is called one-dimensional motion. Okay. For example, we have seen this case. Now let's see what is the two-dimensional motion. When any object moves, or you can say travels, along a curved path on a plane, then it is called two-dimensional motion. Okay, so this is the concept. Now let's see what is the value of distance and displacement in each and every case. For this, first of all, see what are the differences between distance and displacement. Here it is distance and it is displacement. So distance is what? Total path length traveled by any object, and in this case we can say displacement is the shift from initial position to final position. The second, we can say it depends on path, and here we can say it is independent of path. taken by the object. And the third one is, we can say it is a scalar quantity. And here we can say it is a vector quantity. Now, what does it mean by the vector quantity? In our textbook, we are already familiar. Vector quantities are those which having magnitudes and direction, right? But here I just want to say, if any physical quantity is a vector quantity, then it means vector quantities are associated with a sign. It can be positive or it can be negative. The importance of sign is positive and negative. These two signs represent the two opposite directions. We will see in this case one by one. So here, now let's come to this point. When the insect travel from A to B along a straight line, and let's suppose this distance is, suppose it is 5 meter. So in this case, the insect traveling along a straight line, so we can say the total path length taken by this insect is 5 meter. So here in this case I can say distance is equal to 5 meter. Okay. Now if we talk about the displacement for this particular case, then displacement is also equal to 5 meter. Because if you see, the insect started its motion from point A, right? So this is what the initial position. Initial position means at time t equal to 0. And what is the time t equal to 0? This is the instant of time when the observer has started observing the motion of any object, right? So this is the time t equal to 0, and this is what the initial position, and suppose this is the final position. So the shifting between initial position and final position is 5 meter. Okay, so in that case we can say distance and displacement both are equal, and it is a particular case when distance and displacement both are equal, right? So in a straight line path, distance and displacement are equal. Okay, so we can say here in a straight line path, distance is equal to displacement. Okay, so this is the very important point. Now let's see what about this path when the insect has traveled along a curve path. Okay, so here let's assume the path length taken by this insect for this curve path, let's assume it is 20 meter. Okay, so if it is 20 meter, then what is the distance and what is the value of displacement? So as per this distance which we have already written over here, so according to this the path length of this curve path is the distance. So here for this particular case we can say distance is equal to, what is the total path length? It is 20 meter. So I can say distance is equal to 20 meter. And if you talk about the shifting between initial and final point, what is the shifting? So shifting is what? This is the initial point A, this is the final point. So shifting is what? That is still, let's assume it is 5 meter. So the shifting is still, that is 5 meter. Okay. So basically, when we talk about the displacement, it is what? It is the shortest distance. Okay, you can add it here. It is shortest distance. So shift always measure along a straight line, and the distance travel along a straight line is always a shortest distance between any 2 points. Okay, so in this case distance is 20 meter and the displacement is 5 meter. So let's see for further cases. Now let's attach Cartesian coordinate system with the position of an observer and try to understand how we can describe the motion of a moving object. So here let's suppose it is y-axis, it is x-axis, and we know this point is origin 0, 0, and let's assume there is an object which moves like this, and after traveling some distance along positive direction, it takes U-turn and stop at this point. Okay, and let's assume the coordinate of this point is -5, 0. Now the same question, what is the distance and what is displacement? Okay, for this I would be needed the information about this point. So let's take this is 5, 0. So what is the distance? So for this I need to calculate the length of this path, right? So if we carefully calculate it, then we can say this is 5 and this is also 5. So I should add these two 5 together along with this 5 as well, right? So the total path length come out to be 5 plus 5 plus 5. So this is going to be 15 meter. Okay. Now if we talk about the displacement is what? Displacement is shifting between initial and final position. So if we see very carefully here, this is the initial point, or you can say initial position, and this is what? The final position. Okay, and we have seen that shifting is measured along a straight line, right? So what I will do for measuring displacement, I will move from this point to this point like this, because this distance will tell me the shifting between initial and final position. So if you see very carefully, the distance is 5 meter. Okay, distance is 5 meter, right? Is it right? Of course not, because we already mentioned that displacement is a vector quantity and it is always associated with a sign. So here if you consider this is the positive direction, right? initially the particle has started motion along a positive direction, and after taking U-turn it comes back to this point in the negative direction. So in that sense I will include negative sign with this. Is it clear? Okay, so this is what minus 5 meter. Okay, now let's see another example. Suppose this is the same object, but this time it has taken any irregular path and it stops here. Okay, so this is what this is the initial position, and this is final position. And the same question is, I want to find out the distance and displacement. So let's assume the total path length is around, let's assume for the moment it is 50 meter, and here I give you the coordinate of this. Suppose it is minus 5 comma minus 5. Okay, so the distance here in this case, it is 50 meter, right? It is mentioned that the total path length is 50 meter. Now if we talk about the displacement is what? The shifting between initial position and final position. So I will take this length. Okay, and what will be the length? So I can measure it by using this formula. Displacement is equal to, here in this particular case, 5 square plus 5 square. I should take minus 5, right? This is for x coordinate and this is for y coordinate. So it comes out to be 50, right? And it comes out to be finally 5 under root 2 meter. So basically what I have done, I have just applied the distance formula, right? You might be already familiar with this. Okay, so in that sense I have calculated the distance and displacement for this particular case. Okay, now let's see a very beautiful example to understand the displacement and distance. Now suppose it is a circular path which is having radius 10 meter, and a person starts moving from point A and completes full circle. The question is what is the distance and what is the displacement? So here in this case, displacement is going to 0 because there is no shifting between initial and final point, because initial and final points are at the same point. So shifting is 0, that means displacement is equal to 0. Now what about the distance? Distance is nothing but the total length of this circular path. So it is 2 pi r, right? Now let's see another case. Suppose this time this person stops at this point B. What is the distance and displacement? So the displacement, for displacement I should join A to B along a straight line, and if it is r, this is r because this is radius and this is also equal to radius. So by Pythagoras theorem we can say AB equal to 2 under root r, right? I have just skipped the steps, so it is AB equal to 2 under root r, right? Now what is the distance? So here you can notice the distance is the path length of this from A to B. So it is nothing but that is equal to 3 by 4 of circumference of the circle. So this is what the distance, right? If you solve it further, then you can write down 3 upon 2 pi. R is what? Radius is given to us, that is 10. So it comes out to be 15 pi meter, right? So this is the very simple case. Now in the same way, we can take any general point over the circumference of this circular path and we can find out the distance and displacement. Now this is the time to quiz. Here I am taking two questions as a quiz. Let's see what are these. Question number 1 is, let's assume it is the circular path and a man starts moving from point A and reaches at this point B, and it is given the angle made by this line with the horizontal, it is 60 degree. Okay, it is 60 degree. Now the radius of this circular path is given 10 meter. The question is, what is distance and displacement? Similarly, there is a next question. Question number 2 is, suppose this is the triangular path. There are two persons, person A and B. Person B starts his journey from this point and reach at this point B, which is exactly at the middle of this side. Okay, now the person A starts moving along this and reaches at the same point. These two persons reach at this point simultaneously. Okay, and the information is given. This angle is suppose 60 degree and it is given 10 meter. The question is, what is the distance and displacement for this particular case? So that's all for today. So see you soon in the next video. Until then, stay connected and keep watching for further.